National Electrical Code Article 680.22a unrestricts the installation of receptacles within 10 feet of a pool, specifically allowing them only for circulation and sanitation equipment. Because a sump pump does not fall under either of these categories, installing a standard receptacle for it within that zone would violate the code. You have a few options to ensure code compliance. Firstly, relocating the sump pump. Moving the sump pump a minimum of 10 feet away from the pool perimeter completely resolves the issue, making sure the receptacle serving it falls outside the restricted zone. This is often the simplest and most direct solution. Secondly, consider a GFCI protected receptacle. Although not explicitly detailed in the code, some electrical inspectors may allow the installation of a ground fault circuit interrupter (GFCI) protected receptacle closer than 10 feet for non-circulation or sanitation purposes like a sump pump. A GFCI device is designed to quickly cut off power if it detects a ground fault, offering increased protection against electrical shock hazards in damp environments. However, you should never assume this will be approved. Thirdly, install the receptacle outside the 10-foot zone. Placing the receptacle serving the sump pump more than 10 feet from the pool is a straightforward way to comply with the National Electrical Code. This may require running additional wiring to reach the sump pump's location, but avoids any potential code conflicts regarding proximity to the pool. Keep in mind that compliance can depend on your local electrical inspector's interpretation, so it is always wise to seek their approval and guidance. The best course of action is to contact the local electrical inspector for guidance and approval on the specific installation plan. This will ensure that the chosen method aligns with local regulations and interpretations of the National Electrical Code. Seeking clarity from the local electrical inspector is important. They can offer specific guidance based on local amendments and interpretations of the National Electrical Code. Their insights will help ensure the sump pump installation meets all safety and code requirements. When considering these options, several factors should be taken into account. These include the existing wiring, the layout of the pool area, and any local regulations that might influence the installation. It is important to evaluate each option based on these factors to determine the most suitable and compliant solution. When dealing with electrical installations near water, safety should be the highest priority. Regardless of the chosen method, ensure that all wiring and connections are properly grounded and protected from moisture. Using appropriate weatherproof enclosures and wiring methods is also essential to prevent electrical hazards. Here are some important aspects to consider during the planning and installation process. Firstly, grounding. Proper grounding is crucial for electrical safety, especially near water. Ensure that all electrical equipment and wiring are properly grounded in accordance with the National Electrical Code requirements. Secondly, weatherproofing. Use weatherproof enclosures and fittings to protect electrical components from moisture and corrosion. This will help prevent electrical hazards and ensure the longevity of the installation. Thirdly, wiring methods. Select appropriate wiring methods for wet locations, such as using Type UF cable or conduit. These wiring methods are designed to withstand moisture and prevent electrical shorts. Fourthly, GFCI protection. Consider installing a GFCI circuit breaker or receptacle to provide additional protection against electrical shock. GFCI devices can detect ground faults and quickly shut off power, reducing the risk of electrical injury. Fifthly, bonding. Bond all metal parts of the pool and electrical equipment together to create a common ground. This will help equalize voltage potentials and reduce the risk of electrical shock. Sixthly, signage. Install warning signs near the pool area to remind users of electrical safety precautions. These signs can help prevent accidents and promote a safe swimming environment. Seventhly, inspections. Schedule regular inspections of the electrical system to identify and address any potential issues. This will help ensure that the installation remains safe and code compliant over time. Finally, documentation. Keep detailed records of all electrical work performed, including permits, inspections, and maintenance. This documentation can be helpful for future reference and can demonstrate compliance with applicable codes and regulations. When dealing with electrical installations near pools, it is always best to err on the side of caution. Consulting with a qualified electrician and obtaining the necessary permits and inspections can help ensure that the installation is safe, code compliant, and properly documented. In addition to the general safety precautions, there are also some specific considerations for sump pump installations near pools. Firstly, sump pump location. Choose a location for the sump pump that is as far away from the pool as possible. This will help minimize the risk of electrical hazards and ensure that the receptacle serving the pump is not within the prohibited zone. Secondly, sump pump power cord. Use a sump pump with a long enough power cord to reach the receptacle without the need for extension cords. Extension cords can be a safety hazard, especially in wet locations. Thirdly, sump pump discharge. Ensure that the sump pump discharges water away from the pool and other electrical equipment. This will help prevent water damage and reduce the risk of electrical shock. Fourthly, sump pump maintenance. Regularly inspect and maintain the sump pump to ensure that it is functioning properly. This includes checking the pump for leaks, cleaning the impeller, and testing the float switch. Fifthly, sump pump backup. Consider installing a backup sump pump in case the primary pump fails. This can help prevent flooding and minimize damage to the pool and surrounding area. Sixthly, sump pump alarm. Install a sump pump alarm to alert you if the pump fails or if the water level rises too high. This can give you time to take action and prevent flooding. Seventhly, sump pump winterization. If you live in an area with cold winters, take steps to winterize the sump pump to prevent it from freezing. This may include disconnecting the pump, draining the water from the pump and discharge line, and insulating the pump housing. Finally, sump pump replacement. Replace the sump pump every few years to ensure that it is functioning properly and efficiently. This can help prevent unexpected failures and minimize the risk of flooding. By following these safety precautions and best practices, you can help ensure that the sump pump installation near the pool is safe, code compliant, and reliable. Remember to always consult with a qualified electrician and obtain the necessary permits and inspections before performing any electrical work. In addition to the specific considerations for sump pump installations, there are also some general electrical safety tips that everyone should follow. Firstly, never work on electrical equipment while standing in water or on a wet surface. Water is an excellent conductor of electricity, and standing in water can increase the risk of electrical shock. Secondly, always turn off the power at the circuit breaker before working on any electrical equipment. This will help prevent accidental electrical shock. Thirdly, use insulated tools when working on electrical equipment. Insulated tools can help protect you from electrical shock. Fourthly, never overload electrical circuits. Overloading a circuit can cause the wires to overheat and start a fire. Fifthly, use ground fault circuit interrupters, GFCIs, in wet locations. GFCIs can detect ground faults and quickly shut off power, reducing the risk of electrical shock. Sixthly, inspect electrical cords and plugs regularly for damage. Damaged cords and plugs can be a fire hazard. Seventhly, keep electrical equipment away from water. Water can damage electrical equipment and increase the risk of electrical shock. Finally, if you are not comfortable working on electrical equipment, hire a qualified electrician. Electrical work can be dangerous, and it is always best to leave it to the professionals. By following these general electrical safety tips, you can help protect yourself and your family from electrical hazards. Remember that electrical safety is everyone's responsibility. Always be aware of the potential risks and take steps to prevent accidents. When working with electricity near a pool, it's also crucial to be aware of the equipotential bonding requirements outlined in the National Electrical Code. Equipotential bonding involves connecting all metallic parts within and around the pool area to a common bonding grid. This grid includes the pool reinforcing steel, metal fittings, pump housings, and any other metallic components that could become energized. The purpose of equipotential bonding is to minimize voltage differences between these metallic parts, reducing the risk of electric shock to anyone in or around the pool. Here is why equipotential bonding is so important. Firstly, it reduces shock hazards. By connecting all metallic parts to a common grid, equipotential bonding minimizes voltage gradients in the pool area. This reduces the likelihood of a person experiencing an electric shock if they come into contact with two different metallic parts that have different voltage potentials. Secondly, it provides a safe path for fault current. In the event of a ground fault, equipotential bonding provides a low impedance path for the fault current to flow back to the source. This helps to quickly trip the circuit breaker or GFCI, interrupting the flow of electricity and preventing a dangerous shock. Thirdly, it improves the effectiveness of GFCI protection. Equipotential bonding helps to ensure that GFCI devices can effectively detect and interrupt ground faults. By minimizing voltage differences in the pool area, bonding enhances the sensitivity of GFCI devices and allows them to quickly respond to even small ground faults. Fourthly, it complies with the National Electrical Code requirements. The National Electrical Code Article 680 provides detailed requirements for equipotential bonding of swimming pools. Following these requirements is essential to ensure the safety of the pool and to comply with applicable codes and regulations. Here are some key aspects of equipotential bonding to consider. Firstly, bonding conductor size. The size of the bonding conductor is crucial to ensure that it can effectively carry fault current. The National Electrical Code specifies minimum conductor sizes based on the size of the service conductors. Secondly, bonding connections. Bonding connections must be made using approved methods and materials. Connections should be mechanically strong and corrosion resistant to ensure a reliable electrical connection over time. Thirdly, bonding grid installation. The bonding grid should be installed in accordance with the National Electrical Code requirements. The grid should be properly spaced and connected to all metallic parts within and around the pool area. Fourthly, inspection and testing. After the bonding grid is installed, it should be inspected and tested to ensure that it is properly installed and functioning correctly. This may involve measuring the resistance of the bonding grid to ground. Fifthly, documentation. Keep detailed records of all bonding work performed, including the size and type of bonding conductors, the methods used to make connections, and the results of any inspections or tests. This documentation can be helpful for future reference and can demonstrate compliance with applicable codes and regulations. When dealing with equipotential bonding of swimming pools, it is always best to consult with a qualified electrician. A qualified electrician can assess the specific requirements of the pool and design and install a bonding system that meets all applicable codes and regulations. Remember that equipotential bonding is a critical safety measure for swimming pools. Properly installed and maintained bonding systems can help protect swimmers from electric shock and ensure the safety of the pool area. Now, let's move on to discussing some common wiring methods used for pool equipment, including sump pumps. There are several wiring methods that are commonly used for pool equipment, each with its own advantages and disadvantages. Firstly, conduit. Conduit is a rigid or flexible metal or plastic tubing used to protect electrical wiring. Conduit provides excellent protection against physical damage and moisture, and it is often required in areas where the wiring is exposed or subject to mechanical stress. Secondly, electrical metallic tubing (EM). Electrical metallic tubing, or EMT, is a thin-walled steel conduit that is commonly used for indoor wiring. EMT is lightweight and easy to install, but it is not as strong as rigid conduit. Thirdly, rigid metal conduit (RMC). Rigid metal conduit, or RMC, is a thick-walled steel conduit that is used for outdoor and underground wiring. RMC provides excellent protection against physical damage and corrosion. Fourthly, flexible metal conduit (FMC). Flexible metal conduit, or FMC, is a flexible metal tubing that is used for connecting equipment that may vibrate or move. FMC is easy to install, but it is not as strong as rigid conduit or EMT. Fifthly, non-metallic conduit (PVC). Non-metallic conduit, or PVC, is a plastic conduit that is used for underground and corrosive environments. PVC conduit is lightweight, corrosion-resistant, and easy to install. Sixthly, cable. Cable is a factory-assembled group of insulated conductors that are enclosed in a protective sheath. Cable is commonly used for residential wiring and is available in a variety of types, including non-metallic sheet cable or NM cable, underground feeder cable, UF cable, and metal-clad cable, MC cable. Seventhly, non-metallic sheet cable, NM. Non-metallic sheet cable, or NM cable, is a type of cable that is commonly used for indoor wiring. NM cable is relatively inexpensive and easy to install, but it is not suitable for wet or corrosive environment. Eighthly, underground feeder cable, OFF. Underground feeder cable, or UF cable, is a type of cable that is designed for direct burial in the ground. UF cable is moisture resistant and can be used in wet or corrosive environments. Ninthly, metal-clad cable, MC. Metal-clad cable, or MC cable, is a type of cable that is enclosed in a metal sheath. MC cable provides excellent protection against physical damage and is often used in commercial and industrial applications. When selecting a wiring method for pool equipment, it is important to consider the following factors. Firstly, environment. The environment in which the wiring will be installed is a critical factor. Wiring that is exposed to moisture, chemicals, or physical damage will require a more robust wiring method than wiring that is installed in a dry, protected environment. Secondly, code requirements. The National Electrical Code, NEC, specifies the types of wiring methods that are permitted in different locations. It is important to comply with all applicable code requirements to ensure the safety of the installation. Thirdly, cost. The cost of different wiring methods can vary significantly. It is important to consider the cost of the wiring method when making a selection, but safety should always be the primary consideration. Fourthly, ease of installation. Some wiring methods are easier to install than others. If you are not experienced in electrical work, it is best to choose a wiring method that is relatively easy to install. Fifthly, future modifications. Consider the possibility of future modifications to the electrical system. It may be wise to choose a wiring method that is flexible and can be easily modified if needed. For some pumps near pools, underground feeder cable, UF cable, installed in conduit is often a good choice. The conduit provides physical protection, while the underground feeder cable, UF cable, is suitable for wet locations. Always consult with a qualified electrician to determine the best wiring method for the specific application. In addition to the wiring methods, it is also important to select the correct size of conductors for the pool equipment. The size of the conductors is determined by the ampacity, or current carrying capacity, of the circuit. The National Electrical Code, NEC, provides tables that specify the minimum conductor size for different ampacities. When selecting conductors, it is important to consider the following factors. Firstly, ampacity. The ampacity of the circuit is the primary factor in determining the conductor size. The conductor must be large enough to safely carry the full load current of the circuit. Secondly, voltage drop. Voltage drop is the reduction in voltage that occurs as electricity flows through a conductor. Excessive voltage drop can cause equipment to malfunction. The National Electrical Code, NEC, recommends limiting voltage drop to 3% for branch circuits and 5% for feeders. Thirdly, temperature rating. The temperature rating of the conductor is the maximum temperature that the conductor can withstand without damage. It is important to select a conductor with a temperature rating that is appropriate for the environment in which it will be installed. Fourthly, insulation type. The insulation type of the conductor is another important consideration. Different insulation types have different properties and are suitable for different applications. Fifthly, conduit fill. The National Electrical Code, NEC, specifies the maximum number of conductors that can be installed in a conduit of a given size. It is important to comply with these requirements to prevent overheating and damage to the conductors. When selecting conductors for pool equipment, it is always best to consult with a qualified electrician. A qualified electrician can assess the specific requirements of the installation and select conductors that are safe, code compliant, and appropriate for the application. Remember that electrical work can be dangerous. It is always best to hire a qualified electrician to perform any electrical work near a pool. Working with electricity near water can be especially hazardous, and it is important to take all necessary precautions to prevent accidents. Before starting any electrical work, be sure to turn off the power at the circuit breaker. This will help prevent accidental electrical shock. Also, use insulated tools when working on electrical equipment. Insulated tools can help protect you from electrical shock. Do not work on electrical equipment while standing in water or on a wet surface. Water is an excellent conductor of electricity, and standing in water can increase the risk of electrical shock. If you are not comfortable working on electrical equipment, hire a qualified electrician. Electrical work can be dangerous, and it is always best to leave it to the professionals. Electrical safety is everyone's responsibility. Always be aware of the potential risks and take steps to prevent accidents. By following these safety precautions, you can help protect yourself and your family from electrical hazards.